This is Josh White with JW Math Tutoring. In today's video, I'm going to go through some alternate solution methods to problems from the March 2025 and May 2025 official SAT math test. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
For this video, I'm going to go through 8 problems from my March 2025 official SAT math worksheets, and I'm going to show alternate solution methods to them. Most of these have been suggested by commenters on the channel, and you will see the YouTube username of the specific commenter, or sometimes there's multiple, who suggested this method in the lower corner of the screen. For ones that obviously there's nothing listed, those are just ones that I came across or found myself. So again, these are alternate solution methods to the March 2025 4 different, SAT official test problem worksheets that I created. And so I hope you like these, basically these methods that mostly people on the channel have suggested to me. Again, check out the original videos for these problems. Links will be in the description below. Also, the worksheets that these problems are part of, there'll be links to all of those in the description and in a pinned comment on the video below. All right, so I'm starting off with worksheet number 1, problem number 10. So again, if you want a full solution to this, check out the video that this appears in. This is just an alternate solution, so I'm not going to go through everything about this problem in detail. But one thing that you can do on this problem is you can use the shortcut relationship, which is that the area of an equilateral triangle is just equal to the side length times root 3 over 4. So we can use that shortcut formula and we can set that equal to the area. And then that will allow us to solve forgot the square root 3, there we go. That allows us to solve for the side length. So we know now that in this equilateral triangle, the sides are all 10, 10, 10. And now at this point, you could use your 30, 60, 90 special right triangle properties, to basically determine, okay, well this is 5 and this is 5, and therefore this has to be 5 root 3. And that's the answer. K is technically, well, sorry, the height is 5 root 3. And then what you can do is you can basically regress this. I mean, you can see that K is going to be 12 when you go ahead and solve this out, but you could now take this and we could type it in and get 12. So in this problem, these are just a couple steps you could have taken to reduce the work. There's not anything here that's going to solve the entire problem in one step, like some of the other problems that we'll see regarding Desmos, but these are just some things you could have done just to basically cut down on the work of the problem. All right, next, let's go to worksheet number 2, and we're going to start with problem number 4. Okay, so for this one, there are actually 2 different methods that you could do. One method, which I think I may have talked about in some other videos, is that when you go to do the regression, okay, if you just put it in as it's listed and you put in the 2 points, it doesn't work properly. So there's some workarounds for that. One method, one way to get the workaround is to just type in the C value. Sorry, I want to put in 20 here. Okay. So for example, if you notice, if you plug in 0 for x, you take this point and plug it in. This is 0, this is 0. Therefore, you get negative root 370 equals negative c, square root c. Therefore, c has to equal 370. So the first alternate method is just to do the regression as given. But just type in the 370 like this, and now we get the correct answer. And so now we get the correct answer for B. But again, remember what this question is asking for is what's the greatest possible value of m? M is basically an x-intercept because notice h of m equals 0. So we want to know what are the x values that we plug in where this function is 0. Okay, so 2 is the one we already are given, and no. Where's the other one? Okay, it's over here at 185. So 185 is the correct answer. Therefore, this is one kind of workaround to solve this. But here is another alternate way you could do this problem, where you could type it in and use regression and get the answer as well. So what we can also do is we can type in both points to the table. And now what I'm going to do for the regression is I'm going to do it slightly differently. I'm going to basically take this and put it in its factored or its intercept form. So I'm going to do x1 minus a and x1 minus b. Okay, so again, notice here, it's still actually not giving us the correct answer or the correct values. So what you have to do is you either have to type in the 2 here for say for A, or technically you could do it for B, it doesn't matter. For one of the intercepts is the point, or you can also define it down here. Notice when I do this now, okay, so it's still not giving me the correct answer. So let's try this. Let's try typing it in instead. Let's get rid of this. There we go. So, okay, it looks like for this method, and I don't know why this is like this. And let me actually try with A, but defining it. Okay, so in terms of typing the 2 in here for one of the intercepts in this factored form versus leaving it as a constant A, but then defining A, as 2, because it's given in the problem right here, it looks like that part doesn't matter. Okay, so that part's irrelevant. So we could type the 2 in here, we could just leave it how it is now. But the key is, for some reason, we can't add the second point to the table when we do the regression. It looks like something messes up with it. We can only use this 0, comma, negative square root 370 point. And so when we do this, notice now we have the correct graph. Basically, you have over here 185, and specifically B is the other x-intercept that you're looking for. So this one's actually a bit shorter, a bit simpler in that it gives you the other x-intercept value, i.e. the other possible value of m, and now you can easily compare, well, what's the greatest value? Is it 185 or is it 2? Okay, it's obviously 185. So therefore, that's your correct answer, and this is an alternate way to do this problem. All right, now question number 5. There are 2 different ways you could do this one that I did not see at the time or did not recognize. So thank you to the 2 different commenters whose names should appear on the screen at various points in order to solve this. The first way is just using regression. I don't know why I didn't think of this or why I missed it, but if we just take the original expression, okay, and we regress that to the given factored form. Okay, so we have this. I forgot the subscript one. There we go. Okay, now we have to define x1 as a list. I'm just going to use a new trick I have now, which is just do random and then 5 numbers. Okay, notice it gives us values for a, b, and c. So what is the value of a times b plus c? Right there, it's 50. This is the entire problem done in, under 30 seconds. So again, gives us the correct answer, which is 50. And what I did is I did regression between the original expression and the factored form. And then once I do that, it finds basically the only possible values of a, b, and c. And then just type them in, or you could just do it in your head if you wanted to. Okay, so that is one method. Now, here's another alternate solution method that you could use as well. This one is not, basically really not a Desmos method, but it's a different way to think about this. So this is method one. Okay, an alternate method you could use is you could multiply out these two parentheses on the right. So you have, just using FOIL, cx to the fourth for the first, then for the inner bcx squared, for the outer 32x squared, and then the last is 32b. Then you go ahead and you distribute, a to every single term. All right. Now, what you're going to do is you're going to match up the original expression and, basically the coefficients. So we know that 40x to the fourth matches up with acx to the fourth. We know that 240x squared matches up with these two terms. And we know that 32b matches up with 320. All right. So, excuse me, I just noticed a mistake. This is not 32b. This is 32ab. Okay, so now at this point, if you notice, the expression we want is a times b plus c. However, if you multiply this out, it's really ab plus ac. And now we actually know what the values of each of these are. Okay, notice from the x to the fourth term, we know that ac is equal to 40. Therefore, we can plug that in. And notice from the last term, AB is equal to 320. Therefore, AB has to equal 10. 32 times 10 would be 320. 10 plus 40 equals 50. So this is just an alternate approach you could take instead of using Desmos. Probably a little bit more work and probably longer than using Desmos, but again, completely valid solution method. All right, next up, the problem below this, where you have an equilateral triangle and you know its perimeter and you want to find its height. This one's similar, to the first one that I did with the area, except what you can actually do here in terms of solving this is you can notice, okay, so we got 60, 60, 60. Now we draw the height down the middle here, splitting it into two 30, 60, 90 triangles. Okay, if the height is r root 3, that means that this side down here is r and this side down here is r. So all you have to do technically to solve this is just notice that one side, if the height is r root 3, that means one side of the triangle is 2r. So you just do 2r plus 2r plus 2r, or 2r times 3, to set that equal to 796, and just get your answer that way. And that's the correct answer right there. Basically 132.6, 132.7, or if you wanted to, let's see, put it as a simplified fraction, it's 398 over 3. So again, on this problem, this is just an alternate way kind of to think about it, where you can cut out, some of the steps, basically save time on the problem. Okay, next, let's look at problem number 8. Again, we're still on worksheet number 2. And this is one where you're given a point, or excuse me, you were given a set of points. Some of the points had a constant value in them, and you were asked to find the equation of the line. So if you try to do this in a table, just sitting up in a regular table, it actually does not work. However, what you can do in Desmos, and this is actually one of the things that was covered in my ultimate Desmos guide to digital SAT math, one of the advanced regression use cases, is you can define x1 and y1 as a list. And when you do that, what's going to happen is it will actually be able to solve 4K. So we define x1 as a list and put all the x-coordinate points. We define y1 as a list. We put all of the y-coordinate points. And now what we can just do is basic linear regression. y1 mx1 plus b. So notice it finds m, it finds k. We don't need the value of k, but if we did, we could use it there. And it finds b. So it gives us the same slope, which is negative 8 point. Basically, it's negative 8 and 2/3. Or as a fraction, it's going to be, I believe, negative 26/3. And for b, I mean, that's already 4. You can recognize that here from the table, but even if you didn't, it gives you the value of b. So now, the equation of this line is just y equals negative 26/3 x plus 4, or negative 8.666, or negative 0.667, either way. This is how you can do this problem entirely in Desmos using linear regression. All right, next we're going to worksheet number 3 for one problem. It is problem number 3, and it is this function here. Make sure I get the whole thing on the screen. Where basically you have a rational function, and essentially there's an asymptote at x equals 3, and you know two x-intercepts here, 7 and 8. Find a plus b plus c. Okay, so what you can do for this one is you can actually do regression, and it's not going to be exact, but it will be close enough that it will still give us the correct answer. So what we can do is we can enter in 3 points. Okay, so we know that 7, 0 is a point. We know that 8, 0 is a point. And now for the third thing, what I'm going to do is it does not touch the line at x equals 3. That means there's a vertical asymptote. So when x is 3, I'm going to enter in a gigantically large number. Just a bunch of 9s, okay? That's going to function essentially the same as a vertical asymptote. So now what we can do is we can do regression with this form of, x squared plus ax plus b on top, and then on the bottom, 2x plus c. Okay, so now what happens is we have a plus b plus, we have a and b and c. It found values for us. What is a plus b plus c? Okay, notice here again, it's not exact because technically it's putting a point in, an actual finite value in for 3 when x is 3, when in reality it's supposed to be infinity, not 9,999,999. But notice it's close enough, because if you take this answer and you either round it or truncate it to 5 total digits, it's going to be 35.00 or just 35, which is the correct answer. So this is how you could do this entire problem in Desmos by just simulating the vertical asymptote at x equals 3 by using a point for it, with just an extremely high y value here. Okay, next we're going to go to worksheet number 4, specifically, first up, problem number 3. All right, next we're going to go to worksheet number 4 to look at a couple problems. The first one is problem number 3. So with this one, when I initially went over this, I did not know of a way to solve this entirely in Desmos, but then after I learned about regressing quadratics to their intercept or factored form, this one can actually be done entirely in Desmos, basically, in one step. So what I'm going to do first is I'm going to move these two terms over to the left so that everything is equal to 0. Then I'm going to do regression to its intercept or its factored form. So I get negative 4 x1 squared plus 112x1 plus 42 plus px1 minus w. Okay, now for its intercept or factored form, I know the two solutions, or the two intercepts, are w over 2 and negative w over 2. So I can just do x1 minus each of them. x1 minus w over 2, and then technically x1 minus negative w over 2, which I'm just going to simplify to plus w over 2. So now, make my list for x1. Easiest way is just I'm going to do 5 random numbers. Notice here it gives me the value for P, it gives me the value for W, it gives me the value for A. I don't care about P or A. Really, I'm only concerned with this W. So it gives me one solution, which is that W equals 6. If you want the other solution, then what we can do here is we can put in a constraint. Let's make W less than 4, and notice it gives me -7, which is the other acceptable answer. So again, this is how you can use regression to solve this entire problem in Desmos. Basically, we're taking a quadratic expression and regressing it to its factored or intercept form, and that will find the values of W for us. All right, last question we're going to look at here is question number 6. So first, I'm going to show you how to solve this entirely in Desmos, and then second, I am going to show you why the answer always works out the way that it does by hand. Both these brought to you by the same person whose name you should see on the screen right now. All right, so first up, what we're going to do, whenever we have one real solution problems with quadratics, we're going to do regression in the form of basically to vertex form, but the k value, i.e. the y-coordinate of the vertex, is going to be equal to 0 because we want one x-intercept. So we need to do first, we need to square both sides. And then I'm going to go ahead and, so you get k minus x equals x minus 37 squared. Then I move everything over to the right, so I've got everything equal to 0. So I just subtracted over this entire expression. Okay, this is now going to be, again, regressed to its factored form. Or sorry, not factored form, excuse me, vertex form. So we've got x1 minus 37 squared minus k minus x1. Okay, so vertex form a times x minus h x squared, except the k is going to be 0 because we want one real solution, which means we want one x-intercept. Therefore, the y-coordinate of the vertex is 0. So now what we have to do is just set a list. So let's do x1. Again, I'll do the random 5 numbers. Notice it gives us the values for k, a, and h. We don't care about h. We don't care about a. We only care about k. What is the value of 4k? Right there it is 146.99995. Now it should be coming out as exactly 147. I'm not sure why. Why is it doing this? Because if we do 36.75, see there it's exactly 147, but for some reason it's not giving me the right number. So let me see here if I just get rid of this. Yeah, I don't know why. For some reason when I chose random, I guess, notice the RMSE, the root mean squared error, is not 0, which means there's some, whatever decimal value. So for this one instead, I guess if I use, just say 1, 2, 3, 4, 5, now the 4k value is exactly 147. That's the answer we're expecting. That's the correct answer to this problem, based on k being 36.75. So it looks like, for example, like this, you would not want to use just 5 random numbers as your element list for x1. Now, I'm going to show you by hand why, when you have this type of problem, the k value is always 0.25 or 1/4 less than this number right here, whatever it is. So whether it's 37, 56, 3, doesn't matter. Okay, here's the reason why. So we have this original problem here, and instead of 37, I'm just going to put in a generic n to represent this number. Notice, you square both sides, okay? K minus x on the right side. X squared is going to be minus 2xn. You have to FOIL this out, plus n squared. Now, let's go ahead and set everything equal to 0. So we get x squared minus 2xn plus x, just moving this term over, plus n squared, and then minus k. All right, so this is now equal to 0. Since we want one real solution, that means we want the discriminant to be equal to 0, b squared minus 4ac. So b here is technically negative 2n plus 1, like if you factor an x out of both of these terms. This is the b value. A is just, positive 1. And c is this entire expression here, n squared minus k. So b squared, negative 2n plus 1 squared, minus 4 times 1 times n squared minus k. I'm just going to flip these and make it 1 minus 2n, just to make the work a little easier to do. Get rid of this. Come on. Okay, so now we have 1 minus 4n. You have to write this out twice and then FOIL it, and then plus 4n squared. Now here, this is just negative 4, this whole thing. So I'm just going to do minus 4n squared plus 4k. So now let's see what happens. 4n squared minus 4n squared, so that cancels out. So that's actually nice and easy. So notice you get 4k equals, and then add 4n minus 1. Okay. So there's a couple different ways you could look at this. If you're looking for the 4k value, okay, it's always going to be 4 times this number and then minus 1. It's always going to work out like that right here. Okay, so 4 times whatever the number being subtracted from the x is, minus 1, or for just specifically the k value, I mean, we don't want k here, we want 4k, but just for the k value, it's just basically, this is why it's n minus 1/4, or n minus 0.25. So it's always going to work out like this. That's basically a shortcut you could take here. So again, you could just memorize that k would be equal to 37 minus, 0.25. Or you could remember 4k is always going to be equal to 4 times the number minus 1. Okay, and you could go ahead and get it that way. Now let's take a look at some problems from the May 2025 official test worksheets. So the first one I'm going to take a look at is from worksheet number 1. It is problem number 2. You have a third degree or cubic polynomial. You're told of the 3 x-intercepts, and I want to know the value of a here, the coefficient on the x squared term. So there's actually a shortcut formula that you can use for this problem, which is that, okay, and just bear with me, the coefficient is going to be a little different. But if you look at the general form, okay, of a cubic polynomial like this, where a, b, c, and d are the coefficients for the 4 terms, the general form for the sum of the roots is going to be negative b over a. So b is the x squared term coefficient, a is the x cubed term coefficient. So for this problem, that means the sum of the roots is going to equal technically negative a over just 1, because we're already given that the coefficient of the x cubed term is 1. So in other words, we know that if we sum up these 3 intercepts, these intercepts are the same values as the roots, as the solution. So negative 2 plus negative 5 plus 7, that's equal to just negative a over 1, or, I mean, we can just get rid of the 1 on the bottom. Really, it's just equal to the opposite of a. But again here, you add these up, negative 7 plus 7, that's just 0. Okay, divided by negative 1, that doesn't do anything, so just a equals 0. So that's just an alternate way you could go through and figure out this problem if you want to memorize and use this formula for, again, a third degree cubic polynomial. All right, now the next question we're going to look at is going to be from worksheet number 2. It is problem number 3. It's this one where we have right triangle, and we draw an altitude to the hypotenuse. So x is the right angle. I think I put y up here and z down here, and then xw is the altitude that is drawn to the hypotenuse. All right, so wx here, 477, yw, 636. All right, so here is a much quicker, faster, easier way to figure this out compared to some of the methods I showed in the videos. you know that angle y, okay, up here, and angle z right here are complementary angles, i.e. they are two acute angles in a right triangle that, basically have to add up to 90 degrees. What that means is their tangents are going to be reciprocals of each other. Because notice, the tangent of z, if you look at the whole triangle, the whole large triangle overall, is going to be xy over xz. And if you look at tangent y, that tangent of that angle is going to be xz opposite over xy adjacent. So notice these are just reciprocals. So basically what you do is you find the tangent of angle y, and then you just take its reciprocal, and that's what the tan of angle z is equal to. And to get tan angle y, we just look at the small triangle right here, and we say, okay, here's angle y, up here at the top. Tangent's going to be opposite, which is going to be 477, over adjacent, right here, 636. Therefore, tangent of angle z is going to be the reciprocal of this, which is just going to be 636 over 477. That reduces down to 4/3, or 1.333, and that's your correct answer. And so this is just an alternate way, much quicker way you could figure out the answer to this problem. Okay, now the next problem we're going to look at is from worksheet number 3. It is problem number 9. And this is just a method that's a little bit quicker, a little bit faster than the one I demonstrated in the video. So the first start of this is the same as the solution I did, which is to plug in just 0 for x. So you plug in 0, 0, 0, and then that's equal to 24. So you get, 24 is equal to the square root of c. C equals 576. So that part's the same. That's the solution that I did. Okay, then you go ahead and you plug that in. But now what you do is you plug in, let me just erase this so we can see the original function. You plug in 9 for x. So here we have 9 cubed. Here we have a times 9 squared. Here we have b times 9. And here we have the 576. All right, and then we set that equal to 0. 9 cubed is going to be 729. 9 squared is going to be 81. 9 is just 9. And then we have 576, okay? And again, that's equal to 0. Next, what I'm going to do is 729 plus 576. Just combine those, and you can add them together in Desmos. So it's going to be 1305. So now we have this expression, and we can just square both sides. And we get 1305 plus 81a plus 9b equals 0. Now, if we subtract the 1305 over, move it to the right, so it becomes negative, you can just basically factor a 9 out here, and then you're left with 9a plus b, and then just divide by 9. Oops, divide by positive 9, not negative 9. And therefore you get 9a plus b equals negative 145, which is the correct answer. It's just, you can see here, it's a little bit quicker, a little bit easier, and fewer steps, a little bit maybe more intuitive than the method that I showed in the original video. And last, I want to look at question number 10. So for this problem, on the video, going through the explanations took a significant amount of time, okay? Basically, like, it was a ton of work figuring out all the different answers and adding everything together, and even using Desmos in it, it was still rather lengthy and rather time-consuming. However, there is a Desmos solution here that is so much quicker and so much faster and easier that I'm going to show you now, thanks to one of the frequent commenters on my channel. All right, so here is basically the idea. I'm just going to make a little chart here, just so this will... Okay, so we have the first equation, which is the x squared plus 10x plus 20. We have the second equation, which is the x squared plus 10x plus 5. And then we have the third one, which is the x squared plus 20x plus c. Okay. Because what I'm going to type in Desmos is a gigantic long regression statement with R and S and U and T and everything, but I just want to show you where all the various numbers are coming from. Okay, so remember, sum of roots is going to be negative b over a. Product of roots, c over a. Okay, so for the first equation, the sum of the two roots is just going to be negative 10. It's really negative 10 over 1, but we can just make it negative 10. For the second equation, sum of the roots is also going to be negative 10. All right, third equation, sum of the roots is going to be negative 20. Okay, again, negative b over a, b is 20, opposite of that, negative 20, a is just 1. All right, now, product of the roots. First equation, c over a, 20 over 1, which is 20. Second one, c over a, 5 over 1, which is 5. Third one, it's just c over 1, or just c. So now what we do is we go to Desmos and we set up a system. It's really a system of equations with like 6 different equations that we're plugging in. So let me just slide this over. Okay, so here's what we have. We know that the sum of the roots, which is r plus s, for the first equation, and I'm actually going to I'm going to build this out, putting in the first, each corresponding thing at the same time. Okay, we know the sum of the roots of the first equation is negative 10. Then we know the product of the roots, which would just be r times s, okay, is equal to 20. Then we go down to the next one. We know that the sum of the two roots, which is t plus u, is equal to negative 10. And we know that the product of the two roots, t times u, is equal to 5. Okay, so all I'm doing is I'm filling in the sum of the roots from the first one, what number it's equal to from the chart. Product of the roots from the first one, number it's equal to from the chart. Do the same for the second equation. Third equation, same thing. Here's where you have to be careful, because basically the sum of the roots is going to be the r plus u, that's root 1, plus s plus t. So it's all 4 things, and we know that they are equal to negative 20. And then now the product of the roots, here's where you have to be careful. It's r plus u and s plus t. Okay, so root 1 is r plus u, root 2 is s plus t, and they're multiplied, so we have to put them in parentheses, and we know that they're equal to c. All right, so now, if you notice, once I type this whole thing in, it gives me all the values, and these are the correct values. Except that we do need to put in, technically we need to put in it gives us the correct value of c is 95, but we should put in the qualifiers of the fact that r is less than s, okay, which it's already true. It's already giving me the r value is negative 7.23, which is less than the s value of negative 2.76, so I actually didn't need to do that. It met that condition automatically. Now, the t is less than u thing is actually not true, because if you look here, u is the smaller value. So if I put this in, then it'll just flip them. But in terms of finding c, it actually doesn't matter, whether r is less than s or t is less than u. That part is actually irrelevant. So notice you can put these constraints in at the end. I have c is 95. This is the entire thing typed out in Desmos. It's really a system of like 6 different equations that it solves, and it gives you the correct answer in so much less time than all the manual work that I went through solving this the first time. All right, so I hope you enjoyed the solutions to these problems from both the March and May 2025 official test worksheets. If you did, please give this video a thumbs up, subscribe to my channel, and sign up for notifications. Otherwise, any comments about these videos, please do leave them below. There'll be links in the description and in the pinned comment on this video to the worksheets themselves, and also to the original solutions that you can check out if you want to go see them. Otherwise, the June 2025 official test worksheet problems will be out very soon. And if you are looking to improve your knowledge of Desmos to help ace the digital SAT math section, please do check out my ultimate Desmos guide to digital SAT math. It has over 3.5 hours of tips and tricks, and we're now up to almost 60 total practice problems to help you master Desmos.